Okie doke, we're back. Welcome back to day 2 of Astronomy 120. We're going to start off today with video 4. We had 3 yesterday, first one of today. And speaking of today, we're going to talk about different kinds of days. There are actually many, but we're going to talk about 2 important kinds of days. Now, for usually everyday language, you're talking to your friends, your parents, whatever, you say the word day, you mean 24 hours, right? That's just a day. Well, there's other kinds of days than that. We have to distinguish between them. And in order to distinguish between that day, okay, which is known as when we use the word day, we're talking about a solar day. That is 24 hours, right? And that's the time from noon until noon, all right? But that is not, I repeat, not the time it takes the Earth to rotate once, okay? The time it takes the Earth to rotate once is known as a sidereal day. Normally you think of a year as the time it takes the Earth to revolve around the sun once. That's right? That's a year. The time it takes the Earth to revolve around the sun, make one trip around the sun. And a day is the amount of time it takes the Earth to rotate once. That's not quite true. Okay, the time it takes the Earth to rotate once is a sidereal day, and that is not equal to 24 hours. I'd like to show you why that is. By the way, sidereal means as reckoned by the stars, with reference to the stars. Okay, so when Galileo published his first big book in 1610, it was called the Sidereal Messenger, the starry messenger. So sidereal means by the stars, according to the stars. Now, to show you the difference between the solar day, 24-hour day, and the sidereal day, which is the amount of time it takes the Earth to rotate once, I'm going to use this happy little diagram right here. You see the sun there? Very happy. I'm trying to channel Bob Ross here. So let's say that we are on planet Earth and that it is noon. And that means, let's say we're at the equator or wherever, we're somewhere where the sun is directly overhead. It's noon. Our watches say noon. Sun is directly overhead, okay? And then we take a flag, a pink flag, and we stick it in the ground so it points straight up toward the sun. Now I want you to translate that into this picture. If we are on the planet here, this is Earth, by the way, sun, Earth, sun, Earth. If we're on the planet here and we're on this side of it because we're standing here, sun's over our head, Earth's beneath our feet, so we're standing on this side, and we take a flag and we point it, we stick it in the ground, so there's our little pink flag. Now that flag points directly at the sun. I'm going to use the blue here. That points directly at the sun. And let's say that way over here beyond the sun is a star. Way that way. Like 1,000 miles that way is a star, way behind the sun. Okay? You don't think of the sun usually as being in front of the stars, but it's always in front of stars. Right? And you can see that during an eclipse. If you saw the eclipse a few years ago, in August of 2017, when the sun goes behind the moon, you can see all the stars, they all come out. So the sun is always in front of the star, we just don't see it because the sun's so bright. So let's say that there's 3 things in a line here: the Earth, the sun, and the star, way, way, way off the screen that way. Okay, I'm looking at the video here. There should be an arrow right about right there. So the star is way out that direction. Okay, way that way. All right. So what's happening now is the Earth is revolving around the sun. Right? That's what we say when the trip around the sun is known as a revolution, but a spin around on its axis is known as a rotation. So the Earth rotates on its axis, but revolves around the sun. So rotation and revolution are different. The Earth rotates on its axis, and revolves around the sun. So the Earth is not only moving around the sun, it is also rotating. So what's going to happen is between now and tomorrow at noon, this Earth's going to move a little bit. So now I'm exaggerating how far it goes. Let's say it moves to right there. Okay. Now the Earth has completed a single orbit, so as it goes, that flag rotates around and eventually points back toward the star. So when it's right here, pointing directly to the left, is pointing back toward the star, the same star. That star is so far away that both these arrows point towards it. Okay. If it were really close, those arrows would point more in like this. But the further that star is away from us, the more and more those lines are, those arrows are parallel. So at this point, that flag is pointing back toward the star. It has completed the Earth has completed one full rotation. But notice that that flag is not pointing back towards the sun. We need to wait a little bit longer for that flag to rotate with the Earth back toward the sun. So in a few minutes, it'll point down this way. So it's got to move. It's supposed to be an arrow. I'm going to make this a little bit bigger so you can see it. I want this to be clear. Okay, so one rotation later, the flag is right there, but then you've got to wait a little bit longer for it to point back toward the sun. All right. So here at A, okay, it points toward the star. Here at B, it points back toward the sun. And so it's had to pass through an additional bit of rotation right there. Okay. So at A, let me get at A, there's been one full rotation. But at B, oops, it is noon again. So it took less time for the Earth to rotate once and for the flag to point back toward the star than it did for it to rotate once, than it did for the flag to point back toward the sun again. At A, we have had one sidereal day. Right? Sidereal means by the stars. So the flag points here toward the star, and then one sidereal day later, it points back toward the star again. Right? It is rotated from here all the way around once, and then points back toward the star again. At B is noon again, so we now, because it's noon again, this is one solar day. And that is 24 hours. So it takes 24 hours to go from start here to B. It takes 23 hours and 56 minutes for the flag to go from the start position to A. It takes 4 minutes less. So this extra little bit of rotation here is 4 minutes worth of rotation. So when it points to A, 23 hours and 56 minutes have elapsed. By the time it gets back to B, 24 hours exactly have elapsed. So this is our sidereal day, and that is our solar day. Okay, so from the beginning to A is one full rotation. The flag points to the left in this picture. The flag points again directly to the left in that picture. That's one full rotation. That's 23 hours and 56 minutes at sidereal day. For that flag to get around, back around to point back toward the sun again, it has to go through A and then go 4 more minutes of rotation back toward the sun. That's our solar day. That's what we normally call a day. There are 365 and a fourth solar days in a year. So those are your two kinds of days. All right, this is all from section 1.4. All right? I wish I had you in a classroom. I'd say, are there any questions? But, you know, call in my office hours. I'm happy to talk about this with you and help you out with it. All right?